today's daily Leetcode problem. 472 concatenated word. It is marked as hard, but if you do it like um, you can submit in brute force way as well, and the code is also you can see the number of lines. So it's upon to you. But let me, also if you have done some questions like this, word break and some things like this, then it would be more what say like yeah familiar. You would be more familiar with this question, which is kind of the question essence is like based on concepts something like same. Given the array of string of words, right? So you have been given array containing some words, so containing some string and obviously without duplicates. Okay, so makes question somewhat easier, and return all the concatenated word. So concatenated word is like when you concatenate multiple words. Let's say you concatenated three words at a time: dog, cats, dog, and it will make you dog, cats, dog. Like this word is concatenated version of these three words, right? So return all the concatenated words in the given list of words. A concatenated word definition is given, like which can be formed by completely entirely of at least two shorter words in a given array. So at least two words should be combining to form them up. It should not be like, okay, this is the only single, like cats. Cats is the only single word, right? If let's say this cat dog, there was a word, so it is formed from cat and dog. So there are at least uh, two words that you can take out from it. If you see, you can take at least three words out of it, like dog, cats, and then again dog. So yeah, so this is a concatenated word, valid concatenated. Similarly, this is also valid concatenated, like cat, dog, just I just said. This is also valid concatenation because you can take out cat and dog, which is present in this, and separately, yeah. So that is about it. Also, you take out in such a way that overlapping should not be there. So cat should be just a separate word, and the remaining part should form a separate word, right? And so on. So yeah. So the good thing about this is that you are taking the concatenated word from the words array itself, as well as the individual words are from the words array itself. So what you have to do, the logic for this problem would be let's be write just logic. So logic for this problem would be, okay, now you want to make something like this. How you gonna make something like this? Cats, dog, cats. If you see, like it's something like take something and then call on the next part. Take cats and call on the remaining part, dog, cats. Whether this is good. If dog, cats is good, then I will say okay, this is good and this was already good, so complete string is good, right? So this is some bool function is doing this over here. I'm calling into some index. Let's say ID till this part. If it is good, if it is present in set, then count. If it is present, then I'll say okay, this word is fine. Like I'll just say key whether cats is present or not. Like I'm going line by line, like I'm going word by word. First I'll try to, let's say I'm trying to see that whether this is good or not, okay? So the basic logic is for loop for all word in w words, right? I'll see if this is good word, right? If this is w is a good, or then I'll just push back it into something like result vector. I'm creating a vector of result, a vector of string called result. If it is good, I will push back into res. Okay, res res dot push w, right? So this will happen something like, and then I have to return res, like finally all which are good, right? So this is the basic code for this, like just this. If you can implement good function by yourself, so this is the logic for this problem. See every word at a time. So it's not like you can do some trick over here, like don't see every word, because seeing every word like looks because 10 raised per 4 looks somewhat time consuming, but I don't think there is any alternative for that. We will see that also. Okay, so let's later. Yeah, let me just see whether there is an alternative of this or not. Okay, so I just figured out something like this is a try solution. Okay, but basically I was trying to see if there is any solution where they have not iterated over all the words, but I don't think like there's any alternative for this. So you have to iterate for all the words, then see whether it's good or not. Okay, so it's not good, and if this is a function, it will return whether it's good or not. If it is good, then result dot add and at last return result. So this is the logic for him as well. But the one thing which I quite liked about this, yeah, he has used try, so obviously full credits to him. But try, hmm. This is a kind of concept which you can apply in string questions, like wherever unordered map you are doing to store some string. As I did unordered set to store the string, he used try to store the string and to iterate on the string. It makes it quite easier, but I don't think so. Like in this case, it's much helpful, but yeah, in some cases, it's very very helpful even uh when these kind of cases are there. Like when you are just going down 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 and down, like you're just adding. So instead of like for every, I'm not also I'm not calling like s dot substr for every string key. Let's take out, so for example, id say you have to start, and id is your starting point, I is your ending point. I'm not going for every ending point. Obviously I'm going for every ending point, but it's not like x is equal to s dot substr and like id to I. So I'm not using substr function over here to take out the string from id to I. Instead, what I'm doing, I'm gradually adding one character up by up. So it will take, otherwise it will take a lot of time. So by taking one character gradually, it shows that okay, so I'm using some pre-calculated work like which I have already done. But every time taking substr function is not a good idea. But yeah, some people's and many people's have just done that only, substr of 0 to length or whatever is concatenated word dot substr length. Few solution I just saw, like what he is doing. First of all, like this is not alternative. Like you have to go for every string, and then you have to run a function whether it is good or not. It will return if it's good, then push back, then result. Okay, so now over here, this function is also very pretty simple, right? In my case also, in their case also. Instead, if you are applying try, so that we will talk about that. But currently, the logic is that you have to go for every word. Okay. Okay, so here is the thing what I applied in recursion logic. Let's do this. Like how I'm checking whether this is good or not, right? So checking good would be something like okay, it's pretty simple like I just told you. So for example, this is a current string. Check whether good or not. Okay? Check good or not. So what I'll do, I'll start from the starting point, right? I'll try to break it around the first index C. Whether C is present in my, obviously before this vector result, like I'm storing in unordered set, like I just told you, you can store in try also, but I'm using an ordered set of string to store. Let's say it is my store to store all the W, okay? Words or dot begin W words, store all words, WORDS, okay? So this is another stat. So he will, if C was a valid word, which is not in this case, like cat is a valid word, right? So it will not say that C is a valid word. So yeah, I'll try to go for C. Okay, let's take C and call in the rest part. But C, it will not run for C. Okay, I'll not try to take C because this will check set dot count x whether C is present or not. He will return no, C is not present. You cannot take. Okay, okay, so let's move forward. So let's try with CA not present, C80 not present. So whenever it's not present, if X is not present, it's not going into this not checking for the rest part. Simply it's going for the next iteration, and X plus is equal to S of I, the next character and the next character and the next character. Obviously, you could have done this by using S dot sub str sub with the starting index. I have like id and ending index. I have I minus id plus 1 for length, right? Ending index is I. So that's what you can do, but I'm not using that substr function. Instead, I'm just adding one by one. So now cat is something which is present. Okay, so he will say okay, I'm present. So I'll say okay, if you are present, then return something like answer for good for S dogs, right? S dogs. So now it will run for this. Now same logic for this will happen. Like it will go for S, which is not present. S D O G. I don't think like it can go good in this way. Like yeah, I don't think so. So taking out cat, you can see there is nothing which is starting from cat, but yeah, cats. There is a starting from cats. So after this, he'll return me like false. He should return me false because there is no point where he is passing like S dog is something like that. So after this winner he returns false. So I checked for cat. What I'll do, I'll again like say check for S. So whether you got the answer from the next part or not, or whether if it's not valid, then you have to move forward, right? You have to move forward, move forward. Even if it's valid, then you have to do two options, right? So just check for the next part and then move forward. So how you'll move forward then? So yeah, if it is valid, then okay, okay, okay. So you will return. 1. If it is not valid, then still you have to move forward. You have to do x plus is equal to s of I. Nothing changed in that, right? So again, I did cats. So cats again valid. Then cats, then dogs. Cats is also valid. So it will return me true. You don't have to move forward. Like you don't need to tell all the possible ways of splitting this cats, dog, cats, in which so that is the question word brick. So you need to show how many ways possible to split that. So that's why in that case you have to go all. You have to go all even if you found one solution. You have to say okay, let's remove this, let's pop this back, and let's try another solution, then push back all the solution in by something like answer vector. But in this case you got one solution, you return answer, right? Return one, and so it will return from this point, and yeah, answer is it will just add it. So that's a pretty much logic for it, and pretty straightforward and simple question. Should I do implementation? But yeah, there is nothing much to implement also. Like also added s dot erase of I, s dot insert of I, that you can skip, because for example cats dot cats, he'll say ki, okay, yeah, he's also a thing. So that's why I'm erasing. I think that's important. I think that's important. It should not get passed without it, right? Why it's important? Because I don't want cats dot cats is also present in my set, right? But it's not a valid still, because it's not forming out of two. So I need at least two. Now how I'm not checking here at least two or not, right? As you can see, cats, dogs, some like dog, cat, cats. These are not good strings, right? So yeah, erase that, so that it should not be just coming out of its own, but there should be at least two things which are forming him up. So yeah, that's why like yeah. Otherwise, all the string will be answered. Yeah, that's also the thing. Yeah, yeah, yeah. So that's the thing, and then this is a simple recursive function. Also, I applied dv, yeah, to tell you a strange part. When I applied dp in the first, it gave me this time complexity, which is pretty more, and then I removed dp, it gives me lesser and lesser time complexity, right? So yeah, you can do this by dp. So what dp would be? Dp of id would store whether this is a good or not, right? Whether starting from id, if it is good or not. If it is good, then it will return one. So whenever you are going back, actually in this case you are not going back on another way, right? So if let's say he says that okay, this part is not good, or if this part is good, okay, if he says this part is good, dog cats, you don't have to go for anything, you just return one. If it's not good, then also you will not see this. So I don't think there is an overlapping strings. But yeah, whatever I try to did over recursion, you can do this with the tabulation. In that case you will need a dp to just to say that okay, this is a good, and if this is a good, return true, right? Because in this case I'm returning, if it is a good, then you have to. So what I'm trying to say, this is the thing. What I did, he did exactly same thing, full credits to him. But the thing is, he tried tabulation, right? Uh, First thing is same, taking into set, and then created a dp of n comma 0. That's what I did also. Okay, I have removed it. So basically it's a 1d dp, that's what I'm trying to say. And dp of 0 is always valid because you have taken nothing, so it's valid. If dp of I is let's say not dp of I, if dp of I is 0, then you have to continue, right? Okay. And because yeah, 0 is a starting point, I think till that point should be valid. And I plus 1 to j, taking all the next point, right? So take the next point. If and he's also generating all the possible strings by using substr. So if it is present in that, you'll say okay, it's fine. And j minus I is less than n, okay, it's in lengthwise also it's fine. So you will say ki dp of j is equal to 1, which means this point is also good. Okay, so he's marking points as good, right? So he will mark okay, cats as a good point. Okay, this is a good point. Dogs is a good point. And again, cats is a good point. So if your ending point is a good point, then your answer is true. I think that's the thing. Also, he's checking that you don't take complete string. Like in this case, also like, but yeah, my checking would be for taking complete string. I don't even push complete string into this, right? So he have pushed the complete string also. So yeah, that is the thing for complete checking that complete string should not come up. And you can say yeah, dp of n is equal to like last word is equal to 1, then push that. Otherwise, just break, right? Huh. Like otherwise, not otherwise break. If you got the answer, then break. Otherwise, you have to go for other like possibilities. Okay. N square solution. Mine is also, I think, n square. Yeah, I think it's n square. That's about it. I did not found the something like where someone has did it without using like all the iteration over that. Okay, this was the same code. Credits to him. Nice code, yeah. Tabulation. We don't often see tabulation in these kind of things. Whew. You also go for every string and then basic tabulation thing. Very similar code. Problem is not properly judged. Even I feel so when I took. Okay, but yeah, yeah. In this case, you can feel so when I'm taking normal thing without using substr. It's giving me more time complexity. Like if I use substr, I think other people are using substr, same code as me, and then just one line difference. Like instead of taking the previous string, they are doing every time they are generating new substr. So yeah, that is giving them a good time complexity. I don't know. There's a word dictionary, return true, and then minimum length. Okay, so this is I think a good function, or what is concatenated function? Yeah, this is the main function. Sort कर दिया. Why sorting? Don't feel so. Zero size. Looks interesting, but yeah, this is also moved or over all the words dot um size dictionary dot insert. Okay, so he's not inserting everything into dictionary at the first, but slowly he's inserting into that, I think. Na 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 na. Yeah, that's why this is also a good logic. I would say that for having a bigger string, when you're checking on the bigger string, okay, so it will be the concatenated version of the smaller string, obviously. If you have pushed the smaller string into the dictionary, you don't need to worry for that. So, yeah, you can say like lexigraphically, like lengthwise, he sorted lengthwise, right? I think, yeah. So, if you have taken previous string, so no need to like take all before it, just the previous ones are needed. So yeah, that is also the thing which you can do, sort and then just keep on pushing. In this way you are saved from both the things. Like I think sorting obviously will take a more time complexity, but yeah, that's another set may push. I think it's off one, right? So yeah, maybe more time complexity if you use set, then the I think this is a better way, because sorting is same time complexity. Also you don't need to check for like whether the complete string is coming or not, as a so this will make sure that that condition is not also not true. Also you are pushing let's think into the dictionary to check. So yeah, that's what it. Very good, very good. And what's dot I dot size greater than min dot length into 2 and is concatenated. Basically this function is main. I think what dot size is greater than min dot length. Okay, it should be at least greater than min dot length, so that it can be formed from that. So it's concatenated is the main function, and then it push back, and then yeah, going over all the string keys also. Dict dot this, and then min length word outside min length. Okay, same thing, just in different ways. My try, which got MLE. So yeah, try is I think I don't know why this is happening, but try should not give MLE if you implement in a good thing. Name solution is giving TLE on this test case. Is this a naive solution? Do not memorize intermediate use and do not use try additional data structure. Slows down algorithm. I don't know about this, but this is the good thing. Like you don't need to. Why do you don't need to memorize? There is a reason for that, because you are not using it anywhere, right? Memorization is useful when you are using it. Hmm. Yeah, I think DFS memorization is not needed, but if you are doing tabulation, then DP is a must, obviously, and that's also a good way. Okay, so okay, guys, so that's about this today's problem, and pretty much brainstorming we did about this problem. Also word break, you can see this is also a similar kind of a problem, how you will generate all the possible things. So this is a kind of recursive function when you have to go for like every you're creating a vector of string passing into void solve function, and this is like just a trivial part which you have to like to change the format of answer, but answer has calculated in this z just by using this unordered set insertion and by using this empty vector which we do, to fill up the empty vector, and then if empty vector becomes good, then z dot push back v. And this is also the same logic. Id is less than n and x plus plus equal to s of I. Increment this and then check if it is present, then v dot push back, call on the next part, and then pop back also. I think this part is also like just a thoda sa variation is just this pop back function and this function key. You don't need to return anything, you just need to push that into your z all, and that's about it. Okay guys, you can try this question also. Okay guys, that's about, bye.